Hello everyone. Our focus for this video is differentiating using first principle. Now the formula you use is this formula here on the board. It says if you have a function f of x, the derivative of f of x is equal to the limit as h approaches 0, which is equal to h approaches 0, f of x plus h minus f of x all divided by h, right? So I'm just going to show a quick demonstration of how this formula came about. Now, let's say we have a line segment here on an xy plane, right? And we want to find the gradient of this line here. We know that we would need the coordinate of 2 points on the line. So here we have a point. So let's say that we draw a line, broken line from this point going down, and a broken line from this point going across. Now what would be the x coordinate here? Let's call the coordinate here x, right? And let's say that the distance from this point to this point is h. So that means the coordinate of this point here would be x plus h, right? What do you think the corresponding y value would be? This is just be f of x, right? You know, y and f of x interchangeable. That means the corresponding y value for this point would also be f of x plus h, right? So that means the coordinate for this point would actually be x comma f of x, and the coordinate for this point would be x plus h comma f of x plus h, right? So that would be the coordinate there. Now, how do you calculate the gradient of a line? That's just the change in y over the change in x, right? So we know that m, which is the gradient, is equal to y2 minus y1 all divided by x2 minus x1. That's just the change in y over the change in x, or what you call rise over run, right? Now, if we are using these coordinates, how would we use the same idea to come up with this formula? So now, what would be our change in y? Our change in y here, which is m, our change in y would be f of x plus h. So that would be f of x plus h. All of that subtract f of x, which is f of x, right? All of that divided by the change in x, right? So this would be x plus h minus x here, which would be x minus x. That will cancel out. So all we left with is m is equal to f of x plus h minus f of x, all of that over h. But what is f? dy by dx, right? Or f prime of x, right? So we could replace this and put dy by dx is actually equal to this thing, which is f of x plus h, right? Minus f of x, all of that divided by h, right? But here there must be a limit for h, right? Because let's say h is 0, you can't divide by 0, right? So you could see how the limit as h approaches 0, because h cannot be 0, but as it approaches 0, right? Let me just show you a demonstration of the limit there. So let's say that you have a circle, right? And there's a point on the circle, and you have a tangent to this point on the circle, right? So you know the tangent only touch one point on the circle. But let's say we have a line here, which is a secant line, right? And we want to determine the tangent or the gradient at that point there. But let's say where this point is actually 0. But if you notice, if I draw some more secant line that approaches this point, I get an approximated value closer and closer to the tangent line here. So if I draw it like that, it is getting much closer. So really and truly, this formula gives you an approximated value really of what the tangent would be, close to it. Alright? So now let's look at an example. I hope that this explanation would have give you a good understanding of this formula here. So let's say that you have a function, right? And you have a function f of x is equal to x squared. And you are asked to differentiate this function using the first principle. Now, one beautiful thing about using the first principle, you can always differentiate the function before using the power rule. Now, if we use the power rule to differentiate this, we know our answer must be 2x. So that's one thing. So, but I am going to show you how you use the first principle rule to differentiate x squared. So now, we have f of x is equal to x squared, right? So we know we need, in our formula, we need f of x plus h. So what is f of x plus h? We have f of x plus h. We just substitute this in this x squared here. So this would equal to x plus h all squared, right? But what is x plus h all squared? We could expand this. And if we expand this, this would be square the first term, which is x squared, plus, you're going to see if you have x times h plus another x times h, that's going to give you 2xh plus the square of the last term, which is h squared, right? So really, f of x is actually equal to x squared plus 2xh plus h, right? How would we apply the first principle for this? We know that the derivative, which is f of x prime, is equal to the limit as h approaches 0, f of x plus h minus f of x, all of that divided by h. But could we just sub in h into this function? If we sub the value of h, which is 0 here, if we sub 0 into this function, we're going to get the function divided by 0. And anything that divided by 0 is undefined, right? So we can't just sub 0 in there. So the idea is we're going to try to manipulate the function, right? And try to get rid of this h in the denominator. So now we would have equal the limit as h approaches 0. What is f of x plus h? f of x plus h is all of this. So you're going to write that. So you're going to write x squared plus 2xh plus h squared. Subtract, right, f of x. But what is f of x? f of x is just x squared. So this is just x squared, right? All of that over h, right? So the aim is to get rid of this h in the denominator. Why? If we sub 0 in there, we're going to get 0 for the denominator. And we know we cannot divide by 0. So we need to get rid of this h. So what you're going to do is to see f of x, derivative of f of x as the limit as h approaches 0, x squared plus 2xh plus h squared. Distribute this minus to this x squared, this becomes minus x squared, all of that over h, right? We have a positive x squared here and a negative x squared. That means those two can cancel out each other. So this positive x squared is going to take out this negative x squared, right? What we are left back with is 2xh plus h squared all over h, right? Let's just write that. So we know that the derivative of f of x is equal to the limit as h approaches 0. What we are left back with is 2xh plus h squared all over h. Now here we have h in both terms. That means we can factor out a h. So here the limit as h approaches 0. If we factor out h out of the numerator, we have h is equal to, factor out h out of the first term, take this h to divide the first term, which is 2xh, we left back with 2x, plus h squared divided by h, just left back with h, all over h. So now we can cancel out this h. Here we have a h multiplying all of this, so this h cancel out this h. So all we left back with is the limit as h approaches 0, right? 2x plus h, right? So now we can substitute the value as h approaches 0. So this is equal to, you know that f of x prime, which is the derivative of f of x, is equal to 2x plus 0. But what is 2x plus 0? That is just 2x. So therefore the derivative of x squared is equal to 2x. And that is how you would use the first principle to differentiate a function. Alright? So now we are going to look at another example. Let's say that we have a function which is f of x, right? Is equal to 3x plus 4, right? And you are asked to differentiate this function. This is the rule that we use, right? So we know we have f of x already. We need f of x plus h. So f of x plus h. We're going to put x plus h anywhere we see x in this function. So this is equal to 3 times x plus h plus 4. We can expand this to make it simple. So this is equal to 3x plus 3h plus 4, right? So that's what we have. Now, if you differentiate this function here using the power rule, all you will get is just 3. So we know that when we finish with this, we should get 3 for our answer. So therefore, dy by dx is equal to the limit as h approaches 0, right? F of x plus h, which is this, which is 3x plus 3h plus 4, right? All of that subtract 3f of x, which is 3x plus 4, so this is 3x plus 4. All of that divided by h, right? Now, if we're going to distribute this negative sign to each term in the bracket, all will happen that each term in the bracket, the sign will change. So all we're left back with is dy by dx as the limit of h approaches 0. We have 3x plus 3h plus 4 minus 3x minus 4, all of that divided by h. So now we have a positive 3x and a negative 3x, so those can cancel out. We also have a positive 4 and a negative 4, so those can cancel out. So all we are left back with is 3h over h, and h can cancel out h, right? So all we're left back with, dy by dx is equal to 3. See there? Pretty easy. Alright? So now, what we're going to do is to look at another example. So let's say that we have another function, and this function is y is equal to 3x squared plus 2x. And you are asked to differentiate this function using first principle. We need f of x, right? So we know that f of x is equal to 3x squared plus 2x, right? We know we need f of x plus h, so f of x plus h, right, is equal to, anywhere you see x in this function, put x plus h, so this is 3 times x plus h, all squared, plus 2 times x plus h, right? I always like to simplify this part first. So if you expand this part with a square, you're going to have plus, distribute this 2 to each term, that becomes 2x plus 2h, right? Can further try to simplify this to be, distribute this 3 to each term, you get 3x squared plus 6xh plus 3h squared plus 2x plus 2h, right? So that f of x plus h is this. So now we need to find a derivative. So we know that f of x prime, which is the derivative, is equal to the limit as h approaches 0. We have f of x. What is f of x? All of this. So it's going to be 3x squared plus 6xh plus 3h squared plus 2x plus 2h, right? All of that, subtract f of x, subtract, put a bracket, subtract 3x squared plus 2x. So that's 3x squared plus 2x, right? All of this over h. You know our aim is to get rid of this h here. So we know this is equal to the limit as h approaches 0. We're going to have 3x squared plus 6xh plus 3h squared plus 2x plus 2h. Distribute this negative, all the sign will change, so this becomes minus 3x squared minus 2x, all of that divided by h. Can anything be cancelled? We have a positive 3x squared here, so this can take out this negative 3x squared. We have a positive 2x here, so this can take out this negative 2x. So all we are left back with is the limit as h approaches 0, right? We have 6xh plus 3h squared, right? We have this term, plus 2h plus 2h all over h, right? Now we can factor out h out of the numerator, right? So if we factor out h out of the numerator, we have the limit as h approaches 0. Factor out h, we're going to take out a h, take out a h, open a bracket. If you divide h into each term, 6x would leave out of that one, plus 3h would leave out of this one, plus 2, all of that over h, right? So now we can cancel out the h in the denominator because we have this h can take out this h. So what do we left back with? We're left back with the limit as h approaches 0, 6x plus 3h plus 2. Now we can substitute h equals 0 into this. So we know that the derivative, which is f of x prime, is equal to 6x, right, plus 3 times the value of h, which is 0, plus 2, right? But what is this simplified to be? This is a 6x plus 2, because 3 times 0, that's a 0, right? But let's do a quick test. If you use the power rule to differentiate this, what would be our answer? We'll take 2 to multiply the 3. So 2 times 3, that's a 6. So all of this is a 6x, because if you subtract 1 from the power, 6x. And when you differentiate 2x, that just give you 2. So absolutely we are correct. Okay? Let's look at another example. Let's say that we have a function and the function is f of x is equal to the root of x, right? How would you go about this? You know we need to find f of x plus h. So f of x plus h would equal to, anywhere you see x, put x plus h. So this would equal to the square root of x plus h. Right? So we know the derivative of this function, which is f of x prime, is equal to the limit as h approaches 0, right? We have f of x plus h, but what is f of x plus h? That is just root of x plus h, subtract the root of f of x, which is root x in this case, all of that over h. Now, we have a challenge. How are we going to get rid of this h under this root sign? How are we going to cancel out this h? This is interesting. What you can do at this point is to multiply by the conjugate of the numerator and you will get rid of the root sign, right? Now, f of x prime is equal to the limit as h approaches 0, right? You have the root of x plus h minus the root of x all over h, right? And we're going to multiply both top and bottom by the conjugate of the numerator. So this would be times the root of x plus h plus the root of x all over the root of x plus h plus the root of x. Now, let me just explain something. Here, we're not really changing the problem, because technically, we're multiplying by 1 over 1, really. Because once you multiply by both the numerator and the denominator by the same thing, you're not really changing the problem. Basically, you're just creating an equivalent fraction, right? So now, if you look at the numerator and you look at the numerator here, when you multiply these two numerators, this is just a difference of 2 squared. Because if you have a function that says x minus 1 times x plus 1, This is just a difference of 2 squares, right? And all you need to do is to just square the first term, and you square x, that's just x squared. Subtract the square of the second term, which is just y. So that's just that. So you are going to use the same idea for this question here, right? So if we use the same idea, the derivative of f of x is equal to the limit as h approaches 0, right? You square the first term, the root of x plus h times the root of x plus h. All will happen, the root sign will disappear, so all we're left back with is just x plus h, right? Minus the root of x times the root of x. That all will happen, the root sign will disappear, we're left back with x, right? All of that over h times, we're not going to distribute this h to this term, so we keep it in the bracket, which is root of x plus h plus the root of x, right? Now what do we realize? We have a negative x here and we have a positive x here, so these can cancel out. Also, we have a h here and we have a h in the numerator, so this h can cancel out this h. So what do we left back with? All we are left back with is f of x prime, which is the derivative, is equal to the limit as h approaches 0. And the numerator we have 1, so that's just 1 left on the numerator, right? The denominator we have the root of x plus h plus the root of x, right? So now we can substitute the value of h into this function. So f of x prime is equal to, we sub the value in, all we are going to left back with is 1 over the root of x. Instead of writing back h, we are going to put the value of h, which is 0. So that's just 0 plus the root of x. So here, f of x prime is equal to, here we just have root x plus root x, right? So this is 1 over, now if you have 1 root x plus another root x, this is just 2 root x. And that is our final answer there. Alright? So the derivative of this function of root x here, and f of x is equal to root x, is equal to 1 all divided by 2 root x. Alright? Let's look at another problem. Let's say we have a function that says y is equal to 4 over root of x. What do you go about differentiating this using first principle? We need f of x, right? So we know that f of x, y and x are interchangeable. F of x and y is interchangeable, so f of x is equal to 4 over root of x. We also need f of x plus h. So f of x plus h is equal to 4 over the root. Anywhere you see x, replace it with x plus h. So this is just x plus h. Alright? So now, how would you differentiate a function, right, of this sort? We know we need to write our formula, right? So we know that the derivative of f of x is equal to the limit as h approaches 0. What is f of x plus h? F of x plus h is just 4 divided by the root of x plus h. So that's 4. That's 4 divided by the root of x plus h, right? Minus f of x. But what is f of x? F of x is 4 over root x. So this is 4 over root of x, right? And all of this divided by h, right? But dividing by h here is the same thing as multiplying by 1 over h, don't it? So I'm going to put 1 over h here and put multiplying. Same thing. Dividing by h is the same thing as multiplying by 1 over h. Alright? Since I am dealing with a fraction. Now, I want to get rid of this h here. That's the aim, right? What do you think would be a nice way to start? I could try to combine these two fractions to make them one, right? If I try to combine these two fractions, now I'm going to have f of x prime, which is the derivative of f of x, is equal to the limit as h approaches 0, right? We're going to have 1 over h times. If I try to combine these two fractions, how do you subtract two fractions? You find a common denominator, right? So here, what would be my common denominator? If I multiply these two things, that can be my common denominator. So my common denominator would be the root of x plus h, right, times the root of x. Clear there? Then you take this denominator to divide your common denominator. So the root of x plus h divided by the product of this thing. Clearly you can see x plus h, going to take out x plus h, leave you back with root of x. So if you have root of x left, you take the 4 to multiply root of x, and that gives you 4 root of x, right, minus, we are going to take this root x to divide this common denominator, which is, so root x will cancel out root x, leave us back with root of x plus h times 4, and that's going to give us 4 root of x plus h, right? So now what we'll have is that the derivative, which is f prime of x, so the derivative of f of x is equal to the limit as h approaches 0, right, 1 over h times, here what we're going to do, right, what we're going to have here is just 4 root x, right, minus 4 root of x plus h, all of that divided by the root of x plus h times the root of x, right? Alright, do you think, right, at this point, now, how do you think we can get rid of this h here? We can do the same idea by multiplying the numerator by the conjugate of the numerator, but we're going to multiply both the numerator and the denominator by the conjugate of the numerator. So here, I'm going to have f prime of x is equal to the limit as h approaches 0, right? We're going to have 1 over h times all of this, which is 4 root of x minus 4 root of x plus h, all of that over the root of x plus h times the root of x, right, multiply by the conjugate of the numerator, and all you're just going to do is write it back and switch the negative sign to plus. So this becomes 4 times the root of x plus 4 plus 4 root of x plus h all over 4 root x plus 4 root of x plus h. Right? Here we created a difference of 2 square. So when you multiply this term by this term, you multiply 4 root x by 4 root x, f of x prime is equal to the limit as h approaches 0, here, 1 over h, right, times all of times, we are now going to multiply out this part here. So we're going to multiply 4 root x times 4 root x, because this is a difference of 2 squares. So we're going to square the first term and square the second term, right? So 4 root x times 4 root x, that's going to give us 4 times 4, that's going to give us 16. Root x times root x, that's us x, and that's multiplied by 16, so that's a 16x here, right? Minus 4 times 4, that's 16 again, times root of x plus h times root of x plus h. All is going to happen that the root sign disappears, so we get x plus h, right? All of that, right, over the root of x plus h times this dot mean times the root of x times all of this in a bracket. So times 4 root of x plus 4 root of x plus h. Alright? So let's erase this part so we get some more space. So now we can expand the numerator, right? If we expand the numerator, we get f of x prime is equal to the limit as h approaches 0, we have 1 over h times, here this is the 16x, right? So this becomes 16x. If we distribute this negative 16 to each term, this term, negative 16 times x, that gives us minus 16x. Negative 16 times h, that gives us minus 16h, right? All of this over the denominator here, and this is just root of x plus h times the root of x times the 4 root x times 4 times the root of x plus h, right? Now, clearly, you can see that 16 will take out negative 16 here. 16x will take out minus 16x. So now, what we are left back with, the derivative of f of x, is equal to, now we're just going to sub this h into the function. So in the numerator we're left back with minus 16 all over. If you put 0 where h is, all you're going to left back in this term is just root x. So this is root x times root x, that's just x, right? Here you're going to have 4 root x plus 4 root x. That's going to be times 4 root x plus 4 root x. Add 4 plus 4, that's us 8. So that's us 8 root of x. Right? Here you can reduce this. 8 can divide by 16. So 8 into 8, that's us 1. And 8 into 6, negative 16 gives you negative 2. right? So our final answer is the derivative of f of x is equal to minus 2 all over x root of x, right? So that's it there. Thank you for watching, and I hope that this video would have helped you to differentiate a function by using first principle. This was a nice workout, right?